All right, so in this video, we're going to solve a quadratic equation by factoring. Now, there's a lot of words in there, and so let's go ahead and take a second and break it down. So first thing we know is if we're talking about a quadratic. And we've been talking a lot about not just quadratics, but quadratic trinomials. And in particular, quadratic trinomials that are expressions. So we've been looking at ax squared plus bx plus c and saying that that is our quadratic. But we've been dealing with expressions. We're now going to take that and make this into an equation. And what we're going to do is we know that when we see that quadratic equation, that it's going to produce a parabola. And then we've even talked about how to know if that parabola is open up or if that parabola is open down. And we know that when it says the word solve, that what we are looking for are the x-intercepts, or the solutions, or the roots, or the zeros of the function. And that we're going to be using today factoring, and factoring takes and breaks a quadratic polynomial into its factors. And then we know that we use something called the zero product property to help solve that. So we know parts of what these words mean, and today we're going to kind of link them all together to be able to find these solutions or roots or zeros of the quadratic equation that when graphed produces a parabola. All right, so we are asked to solve this equation x squared plus 16x equals -7. So I first noticed that this is a quadratic equation because I have an x to the second power. At this point, I may also notice that the coefficient here is a +1, and so that my parabola is going to be graphed with the shape open up. Now, I don't know where on the coordinate plane yet that this parabola will be located, but I do know that the shape is open up. So I'm going to have to keep that in mind. Now, to be able to solve this, my first step that I need to do is I need to take and set this equation equal to 0. So what that means is that the x squared is going to stay on the left side of the equation. The 16x will stay on the left side of the equation. But then this -17 is going to have to come to the other side. And when it does, it becomes a +17 equal to 0. So my first step here is going to be to set the equation equal to 0. And we want to do so keeping the squared term positive. So I knew I wanted to move the 17 this way as opposed to moving these items this way. The other thing I want to do when I set equal to 0 is I want to make sure that this is in standard form or descending order, that we have the x squared term and then the x to the first term and then the constant term equal to 0. Okay. Now, the next thing that we're going to do is we are going to factor. And so you might want to go off to the side of your paper here and practice factoring this. What I know is that it doesn't have a GCF. It doesn't have 2 terms, but it does have 3 terms. And so I'm going to have to take and draw my box and figure out my factors. And when you do, they get written right here. So right now you need to pause the video and go and factor x squared plus 16x plus 17. And when you're finished, start the video again. So our factors are x plus 16 and x plus 1. Now, after we factor, what we're going to use is that zero product property. And what that tells me is that if this thing is equal to 0 times this thing is equal to 0, then either this parenthesis or this parenthesis must be equal to 0. And so what the zero product property tells me then is to take this parenthesis and set it equal to 0, and then take the other parenthesis and set it equal to 0. And then the last thing that we're going to do is solve. And when we solve, just a one-step equation here, x equals negative 16. That tells me that at the ordered pair, negative 16, 0, the parabola crosses over the x-axis. Over here, when I solve, that tells me that at the point negative 1, 0, the parabola crosses over the x-axis. And so let's review our steps here. Our steps are, after we determine that we have a quadratic equation by looking at that we have it to the second power, we take and set the equation equal to 0, keeping this x squared term positive, and then our terms in descending order of degree, x to the second, x to the first, constant. After that, we factor, and that could be any type of factoring, greatest common factor. It could be a quadratic trinomial where we use the box. We have to go and factor and get those factors, and those factors go here. So that might require some work off to the side. After we do that, we use that zero product property, which just tells us if we're multiplying this times this and the answer is 0, then either this is equal to 0 and or this is equal to 0. And so therefore, we then solve these two little equations. And what that now tells us is that at the point negative 16, 0, which would happen to be, this is that idea of sketching, we're not being perfect, negative 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Negative 16, 0, and the point negative 1, 0, that we know that our parabola crosses over the x-axis, and we already knew that our parabola was open up because our a value was positive. And so a sketch would look just like this. So in this one, we have x squared minus 9 equals 0. And so we look at this and we recognize it's a quadratic equation. The first thing I want to check for is to see, is it set equal to 0? And it is already set equal to 0. And so that step is already done for us, okay? So step 2 now is going to be to factor. This is where, if you need to, you step off to the side and you go through your factoring flowchart. We're going to run through it very quickly right now in our heads and say if I start with x squared minus 9, we do not have a greatest common factor. I follow it down to a binomial. Binomial means there are two terms. and I look for the pattern of perfect square minus perfect square, which I do see here, which leaves me with an x plus 3 and an x minus 3. All right, my next step is to use the zero product property. And it says that if we have this times this equal to 0, then either this and or this is equal to 0. And so we're going to have to take and say this equation equal to 0 and this equation equal to 0. And then our fourth step is to solve these equations. And so when I solve this one, I get a -3. And what that tells me is that at -3, 0, there's an intercept. And when I solve this one, this tells me that at 3, 0, there's an intercept. And if I look at the original equation, you know, my ax squared here, my a is positive, and so then that would tell me that this is shaped open up. And you can check back with the last slides, same 4 steps that we do when we solve by factoring. All right, so in this equation, we see that it is quadratic, that we have that x squared. And so our first step we check for is to make sure that it is set equal to 0. And it already is, so that part is done. The second thing that we want to be able to do is to factor. And so what I see here is that this is a quadratic trinomial. There is no GCF. And so I'm going to have to go and set up a box. I also notice that this a value is greater than 1. So this may be one that you have to persevere through in getting that factored. Okay, so if you need to pause the video for a second and take some time to factor that. And when you're done, hit start. All right, so when we factor that, we should have come up with that one factor is 2x plus 1, and the other factor is x plus 6. And if I check myself, 2x times x is 2x squared. 1 times 6 is 6. And if I multiply the outer times the inner and add, that would give me a 13. So I have that factored correctly. The next thing that I want to be able to do is I need to take and use the zero product property, which tells me that either that first parenthesis must be 0 or the second parenthesis must be 0. And then the next thing that we're going to do is solve. And so when I solve this, I need to move the positive 1 and then divide by 2. I'm going to get x equals -1/2. And so that tells me that over here at 0, 1, 2, -1/2 right here is one of the intercepts. And then when I solve this equation, what I find out is that this is at -6. So 0, 1, 2, 3, 4, 5, 6. Right here is my other intercept. And in my original problem, the A is a positive. And so that tells me when I sketch this that I'm going to have this open up. Now remember, what we're doing here is a sketch. We're merely just identifying that we know that when we find these solutions, that they are the places that it crosses over the x-axis, that the graph crosses over the x-axis, and that we know what shape it is by looking at this leading coefficient. we'll get to later when we do a very specific point-by-point graph of this, but right now this is just a sketch. All right, in this last one, x squared plus 10x equals 0. We check to see first, is it set equal to 0? And it is. So set equal to 0, and that is done. Remember, these notes that I'm keeping over here on the side are just helping me remember these 4 steps that I want to practice every time. The second thing that I want to do is I want to be able to factor. And when I look at this factoring here, the first one I think of is a GCF. And this one does have a GCF of x. So I'm going to take and factor out an x. And when I do, I would be left with x plus 10 equals 0. And so I wanted to show you that this could work when you also just have a greatest common factor. We're still going to follow the same steps. So our next step would be to use that 0 product property and to say that treat this as almost as if it's in parentheses, as well as setting this equal to 0. Now what happens is that in this 4th step where we go to solve, we don't have to here because this is already one of our roots. It's at the origin, the solution is at 0, 0. And so now we just have to find out where the other one is. And when I solve this, I'm going to find out that it's at negative 10, 0. And remember that this is just a sketch. We're not trying to perfectly space these. We're just showing that we know the general location of that this is at 0, 0, and that negative 10, 0 would be over here. And now I know that this is 1x squared, and that would be positive. And I know that my parabola would be generally shaped like this. So remember, when we're talking about sketching, we're just talking about the x-intercepts and the shape. Is it open up or is it open down?